Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. We are learning the chapter Purification and Characterization of Elements in Organic Compounds from the class 11. Today in the session, we are going to learn about quantitative analysis of organic compound. Quantitative analysis of organic compound. In that, we are learning about the estimation of nitrogen. Estimation of nitrogen. Let us start the session. So quantitative analysis, especially in quantitative analysis, what do we study? We quantitative analysis of what? Organic compound. Organic compound. In quantitative analysis of organic compound, we estimate the percentage. What do we do? Estimate the percentage of element. Estimate, or we find the percentage of element in organic compound. Here in this session we are going to estimate nitrogen. How much amount of nitrogen is present in the organic compound, or what is the percentage of nitrogen present in organic compound? So nitrogen present in the organic compound is estimated by two methods, very important methods, which competitive examinations focus on these methods. If you look into previous year questions from this quantitative analysis of organic compounds, you will find more questions on Dumas method and Zeldal method. Okay, so there are two methods to estimate the percentage of nitrogen present in the organic compound. What are those two methods? One is Dumas method and there is a Zeldal method. Right? So let us discuss Dumas method. What is Dumas method? In Dumas method, organic compound, see, nitrogen present in organic compound is converted into nitrogen in organic compound is converted to molecular form of nitrogen. Okay, so what is this N2? Nitrogen exists as N2. So molecular form. So nitrogen present in the organic compound is converted into N2 gas. Right? So looking this apparatus is Dumas method. Right? Now you can see here you are passing carbon dioxide. Okay. So what is this completely called? This is furnace. Furnace means you are heating it. So this chamber is called as a combustion tube. What is this called as a combustion tube? So you are heating the organic compound with cupric oxide. What you are doing? You are heating the organic compound with the cupric oxide. Right? You are finding here CuO plus organic compound. Is this a CuO plus organic compound? Here, let us see this part. In this part, copper oxide is present and organic compound is present. And your furnace, this is furnace. Furnace means where you are heating that. What you are doing? Heating. Furnace means what? Heating. You are heating this cupric oxide and organic compound combinedly. Okay, so when you heat it, what happens? In the presence of in the presence of carbon dioxide, initially you are passing this carbon dioxide. Why you are passing this carbon dioxide? If there is any air present in this furnace, that air will come in this direction. It will be coming over this KOH solution. What is this called as? This is a KOH solution. KOH solution. Okay. What is this instrument called as? This instrument is called as what? Nitrometer. Nitrometer. Right. So when you are passing carbon dioxide into this, initially, if there is any air in this, or if there is any air present in this combustion tube, that will come into the nitrometer and that will occupy over KOH solution. Over KOH solution. Okay. And now what you are doing, you are opening this valve. When you open this valve, the air above this KOH solution escapes, and we should make clear that we should see that this KOH solution is completely filling this nitrometer. What is that? KOH solution is up to the top, up to the surface, up to here, without any air. How can you do this? By pulling up and down. So there is a flask here. This is also containing KOH solution. It is connected to this. Okay. Now you can pull up and you can pull down. When you pull up, then this KOH solution also is pulled up. It comes to up to this valve. It is completely filled without any air gap. So you have to see that the air present in this apparatus is pushed out by opening the valve. After filling the KOH solution up to the surface, you have to close the valve. For closing the valve, now again you are bringing this flask down. When you move down, automatically it moves down. Some vacuum is created here. Over the nitrogen, over the KOH solution, there will be some vacuum. Okay. So that is the purpose of carbon dioxide, passing carbon dioxide. So what is the purpose of passing carbon dioxide into this? To replace the air, to send the air out. Air should not be there in this. Then now what you are doing, you are heating organic compound with CuO. Then what happens? When you are heating with carbon dioxide, organic compound with CuO, let us see this. Organic compound contain carbon, CXHY, OZ. CXHY, let us take the NZ. Organic compound contain carbon, hydrogen and nitrogen. This is reacting with the cupric oxide. Cupric oxide. 1 mole. If nothing is present, what we say? 1 mole. When it is reacting, what are the products formed? CO2 is formed, H2O is formed, N2 is formed, and Cu, copper is formed. What is that? Copper will be formed. If you balance this, you will find 2x plus y by 2 x CO2, y by 2 H2O, z by 2 N2, and 2x plus y by 2 CO. So this is the balanced equation for the reaction of organic compound containing nitrogen when it is heated with cupric oxide. What are the products formed? What are the products formed? Carbon dioxide, water, copper. Anyway, it is solid, it remains in this combustion tube. As carbon dioxide, water and nitrogen are gases, they move forward. They move forward. Okay. Now, it is found that some nitrogen, as it is reacting with cupric oxide, it is converted into oxides of nitrogen. Oxides of nitrogen. So, it is found that some nitrogen of organic compound reacts with the cupric oxide and produces oxides of nitrogen. Oxides of water, nitrogen. So along with carbon dioxide, water, nitrogen, some oxides of nitrogen are also produced. But what do we want? We don't want this oxide of nitrogen. We want nitrogen. We are calculating nitrogen in the organic compound in the form of N2. So these oxides of nitrogen, what they are done? Oxides of nitrogen are reacted with, see, copper gauge, reduced copper gauge. Okay, so copper metal in the form of thin wires is called as copper gauge. So oxides of nitrogen, here released oxides of nitrogen, when they are passing through this copper gauge, then they are converted into cupric oxide again and nitrogen gas is evolved. So if some nitrogen present in the organic compound is converted into oxides of nitrogen, when it is passing through this reduced copper gauge, it is again converted into nitrogen. So overall, finally, what is coming through this tube? Through this combustion tube, what is coming? Carbon dioxide. What is coming? Carbon dioxide, nitrogen and water vapor. So copper remains in the combustion tube. So when it is passing through this tube and it is passing through KOH solution. So this KOH solution, what does it do? KOH absorbs carbon dioxide. What does it do? KOH absorbs carbon dioxide. And this nitrogen gas along with water vapor is occupying the upper region of nitrometer. Okay, so what is formed here? Here nitrogen plus water vapor. Okay, so moist nitrogen. What is that? Moist nitrogen. Moist nitrogen means dry nitrogen plus water vapor. Okay, water vapor is collected, collected over KOH solution. Now, by calculating the volume and pressure of moist nitrogen, you can calculate the volume of dry nitrogen. So pressure exerted by moist nitrogen is equal to pressure exerted by dry nitrogen plus pressure exerted by water vapor. And we know that pressure exerted by water vapor is called as aqueous tension. Aqueous tension. So tension means pressure, aqueous means water. So pressure exerted by water vapor is called as a aqueous tension. So this is how the procedure proceeds in Dumas method, where over this KOH solution, nitrogen along with water vapor is collected, moist nitrogen is collected. So here this nitrogen is estimated. Let us see the next part. So in this method, nitrogen present in the organic compound is converted into molecular nitrogen. A weighed amount of organic compound is heated with cupric oxide in the atmosphere of carbon dioxide. Already we have seen. What is the purpose of using carbon dioxide? To replace the air. This equation also we have seen. Carbon and hydrogen present in the compound are oxidized due to carbon dioxide and water, whereas nitrogen is set free. So this equation, based on this equation also we are asked questions. Okay. So traces of nitrogen oxide formed, if any, are reduced due to free nitrogen by passing over copper gauge. So these points are important. Based on these points we have PYQ. Based on this point we have PYQ. Copper gauge. You have to remember this. So oxides of nitrogen plus copper gives you, this is copper gauge, gives you again nitrogen is released. So if there are any traces of nitrogen reacting with oxygen of copper oxide to form oxides of nitrogen, that is again converted into nitrogen by passing over copper gauge. Mixture of gases produced is collected over caustic potash, which is also called as KOH solution, which absorbs carbon dioxide. So nitrogen is collected in the upper part of the nitrometer. Already we have seen all these procedure. Okay. Now coming to deriving the formula, we know percentage of nitrogen in organic compound, mass percentage means mass of nitrogen by mass of organic compound into 100. So this is the formula to calculate the percentage. Whose percentage you are calculating? Nitrogen. Where that nitrogen is present? The nitrogen is present in organic compound. So we are calculating the percentage of nitrogen in organic compound. Percentage of nitrogen is equal to mass of nitrogen by mass of organic compound into 100. Okay. When you consider molar volume, let us take molar volume, you are considering it as 22.4 liters at the STP. Okay, that means you are taking temperature 273 Kelvin and pressure is equal to 1 atmosphere. Then molar volume will be this. From this we can say that as nitrogen is released in the gaseous form, 1 mole of nitrogen gas at STP. We are taking these STP conditions, these conditions. 1 mole of nitrogen at STP occupies how much? 22,400 ml. That means 1 mole of nitrogen gas means 28 grams occupies 22,400 ml at STP. Okay. Then we do not know how much ml of nitrogen is released. Let us take VML at STP. Occupies. Let us take it as X grams. If you calculate what is X? X is the mass of nitrogen. What is that? X is mass of nitrogen. Calculate X now. Find X, cross multiply it. X is equal to 28 into VML by 22,400. Okay. So let me take it as equation 2. Let me take this as equation 1. Substitute equation 2 in 1. Substitute, okay, equation 2 in 1. Then what do you get? Percentage of nitrogen is equal to 28 by 22,400 into VmL by weight of organic compound into. So this is the formula. So what is VmL? Volume of nitrogen in ml at HTP. What is V? Volume of nitrogen gas in ml at STP conditions. Understood? So this formula is important because based on this formula we are asked questions in different competitive examinations. So this formula you need to remember. In the examination you cannot derive all these things. Okay, because we are given limited time. Within that limited time we have to solve the question. So we should try to remember the formula and we should remember the formula. Okay. So that is about Dumas method. Dumas method. So let us solve some questions PYQ on this Dumas method. Okay. So when the question is asked in 2023 JEE Main. In Dumas method for estimation of nitrogen, the sample is heated with cupric copper oxide and the gas evolved is passed over. Now only we have seen the gas evolved is passed over copper gas, because why we are passing this over the copper gas? To convert the oxides of nitrogen into nitrogen gas. Oxides of nitrogen when passed through copper gauge converted into cupric oxide and nitrogen gas. So to convert any oxides of nitrogen formed during combustion into nitrogen gas, we pass the gas evolved over this copper gauge. Understood? Next. Asked in 2025, very much recent examination. Dumas method is used for estimation of nitrogen in an organic compound. Yes, correct. Dumas method is used for estimating nitrogen. Next, statement 2. Dumas method involves the formation of ammonium sulfate by heating the organic compound with H2SO4. No. Dumas method involves organic compound is heated with cupric oxide, so that carbon present in the organic compound is converted into carbon dioxide, hydrogen present in the organic compound into water, nitrogen present in the organic compound is converted into nitrogen and copper. So this is involved in Jaldal method, not in Dumas method. So statement 2 is wrong. Statement 1 is correct. So statement 1 is true and statement 2 is false. Understood? Okay, next question. The transformation occurring in Dumas method is given below. So what do you write? CXHYNZ. So here what is that? CXHYNZ. Here as the value of y is, what will be the value of HY? H7. So answer will be 7. Simple, very much simple question. So now looking into this, okay, it will be easy because now we are dealing with this chapter, we are learning this and we will be able to remember. But you are not writing examination on one chapter, right? You are writing the examination on the complete chapters, complete whole chemistry. So when considering whole chemistry, when you are learning all those concepts, you should be able to remember this formula. In chemistry, learning process means remembering the things is also a part, the main part in learning process. You may be thinking that why should we remember all these things? Should we revise, remind? Yes, we have to revise, remember. Remembrance is the main part of learning process. So you need to remember this formula. So when you remember this representation, then you will be able to understand Cx, Hy, Nz. So y will be equal to correlating between these two, then what you get, y is equal to 7. Understood? Let us see the next. The number of moles of cupric oxide that will be utilized in Dumas method for estimating nitrogen in a sample of 57.5 grams of NN dimethyl amino pentane. Okay, so let us see here. NN dimethyl amino pentane. First write amino pentane. Pentane amine. You can also write pentane amine. Amino pentane. Amino pentane. So CH3, CH2, 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 NH2. This is amino pentane. This is primary amine. This is amino pentane. 5 carbons are there. 1, 2, 3, 4. This is amino pentane. Okay. So 5 carbons must be there. 1, 2, 3, 4, 5. So what do we say? Amino pentane. But question asked is not amino pentane. NN dimethyl. So to this nitrogen, 2 hydrogens are attached. Are there 2 hydrogens? These 2 hydrogens are replaced with what? Methyl groups. What are those? Methyl groups. So if substituent is attached to carbon, we write number 1, 2, 3, 4. But if substituent is attached to nitrogen, we write N. That is the way of representing. So 2 methyl groups are attached to the same nitrogen. I can write N, comma N, dimethyl. Okay, dimethyl amino pentane, right? So what is the molecular formula of this? There are 7 carbon atoms. So C7. How many hydrogens are there? 3 plus 2 plus 2 plus 2 plus 2. 8 plus 3, 11. 11 plus 6, 17. H, 17. N. Okay, molecular weight is 12 into 7. 12 7 is 84. 17 into 1, 17. 14 into 1, 14. Then what do you get? 15, 115. So molar mass is 115 grams. Molar mass is 115 grams. If I want to calculate the number of moles, so number of moles of NN dimethyl pentane, number of moles, like number of moles of C7H17N is equal to number of moles is equal to weight by molecular weight. Weight given 57.5 grams by molar mass, gram molecular weight is equal to 115 grams. If you divide it, you get 1 by 2. So number of moles we have calculated 1 by 2. Okay. So from the equation, before we have seen one equation. What is that equation is? We have seen this equation. What is that? CXHYNZ reacting with 2x plus y by 2 CuO gives XCO2 plus y by 2 H2O plus Z by 2 N2 plus 2x plus y by 2 Cu. This is the equation. From this balanced equation, I can write that 1 mole, this is 1 mole, no? Right? 1 mole is reacting with these many moles. 1 mole of what? CXHYNZ reacts with so question asked is, you see, how many moles are utilized in Dumas method for estimating, right? 1 mole reacts with 2x plus y by 2 mole of Cu. Okay. So how many moles are there in 57.5 grams? Half mole. So 1 by 2 moles of this CX HYNZ reacts with how many? 2x plus y by 2 by 2 moles of Cu. And from the equation, we have studied that what this formula, half mole of so in the formula, what is the formula? What is this 1 half mole of what is this? I can write this as C7 H17 N1. Okay, half mole. So in the C7 H17 N1, X is equal to 7, Y is equal to 17, N is equal to 1, right? So X, multiply X here, 2 into 7 plus Y is 17, 17 by 2 by 2, that is equal to 14 plus 8.5 by 2, that is equal to, what do you get? 22.5 by 2, that is equal to 11.25. Okay, so these millimoles. But the question asked is into 10 power minus 2. In the terms of what he has asked, into 10 power minus 2. I can write this as 1125 into 10 power minus 2 mole. So what will be the answer? 1125. 11. So the answer will be here 1125. Right? Understood? Next, let us see the next. This is asked in 2024. During the estimation of, previous question is asked in 2021. Okay, this question, let us see. During the estimation of nitrogen by Dumas method of compound X, what is given? The compound X is given, its mass is given 0.42 grams. So here is the compound X. If you detailedly write this compound, how will you write this compound? NH, right? CH2, CH2, NH, right? CH2, CH2. So this is the compound. Let us write the molecular formula of this compound. How many carbons are there? 4 carbons. So C4. How many hydrogens are there? 2 plus 2 plus 2 plus 2 plus 2. 10. C10H2. Then calculate molecular weight. Molecular weight 4. 12 into 4, 48. 10 into 1, 10. 14 into 2, 28. 16. Okay. Then 86. And if I ask to calculate the number of moles of moles of C4H10N2 is equal to number of moles is equal to weight by molecular. So weight given how much? 0.42 grams. So 0.42 grams by 86 grams. Okay. So what is that? We got number of moles. What is that? Number of moles. But the question asked is dash ml of nitrogen gas will be liberated at STP. So Dumas method, this compound is undergoing the process of Dumas method. When it is undergoing the process of Dumas method, how much nitrogen or what is the volume of nitrogen in ml liberated at STP? Liberated at STP. We know that formula we know, right? 1 mole of CXHYNZ produces this formula you can see. This one you can see here. So this is 1 mole, right? 1 mole. 1 mole is producing how many moles of nitrogen gas? Z by 2. 1 mole of organic compound is producing Z by 2 moles of N2, right? So now I can write produces or liberates, okay, Z by 2 mole of nitrogen. If you look into this formula, C4H10N2 correlate with this CXHYNZ, right? This is N2, this is NZ. Then what will be Z? Z is equal to 2, no? It is equal to 2. So now how many moles instead of the CXHYNZ? Now I can write that 1 mole of what is that? C4H10N2 produces or liberates. What is Z? Z is 2 by 2, right? Mole of nitrogen gas at ST. So 2 by 2 is 1. How many moles? 2 by 2 mole. 1 mole occupies how much volume? 22.4 liters. But here actually STP, what you have to do? Actual STP means STP, standard temperature and pressure. So standard temperature is actually 273.15 Kelvin. Standard pressure is equal to 1 bar pressure. If you take these two conditions, what will be molar volume? Molar volume will be 22.7 liters. Okay. So now 1 mole of this is producing 1 mole is producing 1 mole of nitrogen at the ST. But how many moles of C4H10N2 are given? You have calculated 1 mole C4H10 N2. This is N2 gas. 1 mole produces 1 mole. Okay. Here, how many moles we have calculated it? 0.46, 0.42 by 86 mole produces, let us take Y. Let us take it as not Y, something like P. What is that? P. P mole. So what will be P? Cross multiply it. Cross multiplication we get 0.42 by 86. What is this? Moles. Is this moles? Moles at ST. P means what? Volume of nitrogen gas. That is equal to 0.42 by 86 into 1 mole occupies how much volume? Normally we have seen that this is 22.7 liters. So if you calculate this, what you get is 110.8 ml. That is equal to 111. Okay, nearest integer. 1118 ml. 111 ml, right? So what do you have? 111 ml. Understood? Let us move to the next one. In Dumas method, for the estimation asked in 2025, estimation of nitrogen, 0.5 grams of an organic compound gave 60 ml. So weight of organic compound is equal to 0.5 grams. Volume is equal to 60 ml. Whose volume? Nitrogen gas collected. Temperature is equal to 300 Kelvin. Okay. Pressure is equal to 715 mm. But we know that this is in Dumas method we get moist nitrogen. Pressure of moist nitrogen is equal to pressure of dry nitrogen plus aqueous tension. This we have studied. Pressure exerted by dry nitrogen is equal to pressure of moist nitrogen minus aqueous tension. Okay. Pressure exerted by moist nitrogen is given as 715. So 715 mm minus aqueous tension is given as 15 mm. So 15 mm, that is equal to 700 mm. So we have to take here how much? 700. We are taking exclusively pressure of nitrogen, dry nitrogen. So 700 mm. But when you are applying the formula percentage of nitrogen in organic compound is equal to, we have derived the formula 28 by 22,400 into volume of nitrogen in ml at STP. Nitrogen in ml at STP by weight of organic compound into 100. So in the formula we have volume of nitrogen gas in ml at STP conditions. Taking here STP conditions is okay. STP conditions, temperature we are taking it as 273 Kelvin, not 273.15. Calculation will be very difficult. Okay. Then now pressure is equal to 760 mm, 1 atmospheric pressure. Then we want this volume, and we have a formula. This is V1 T1 P1, V2 T2 P2. Then we have a formula from gaseous state. We have studied that P1 V1 by T1 is equal to P2 V2 by T2. Then V2 is equal to, okay, P1 V1 T2 by P2 T1. So which is equal to P1 700 into V1 60 ml into T2 273 Kelvin by, okay, I'm not using the units, right? P2 760 into T1 300 Kelvin. So this is the volume at STP, nitrogen. Now substitute that volume in this equation, then percentage of nitrogen in the organic compound is equal to 28 by 22,400 into volume of nitrogen is 700 into 60 into 273 by 760 into 300 by weight of the organic compound. Initially it is given as how much? 0.5 grams. It's given 0.5 grams. So 0.5 grams into 100. Okay. So then what you will get? So you will get it as 12.57% on calculation percentage. So do we have that option? Yes, we have that option, 12.5%. Very recent examination it is asked, 2025. Okay. So such questions, this pattern questions, there are 5 PYQ. Previous year JEE Mains, if you look into the papers of JEE Main, you will find similar pattern questions, about 5. So you have to understand the importance of this pattern or model question. This model question is asked repeatedly, very repeatedly. So we have to practice this model question. Understood? Okay. So let us see the next question. Again, Dumas method. Okay, Dumas method. 0.2 gram of organic compound was subjected to estimation of nitrogen by Dumas method, in which volume of nitrogen evolved at STP was found to be 22.4 ml. The percentage of nitrogen in the compound is molar volume given 22.4 ml. Okay. Direct formula you can use. What is that? By Dumas method, percentage of nitrogen is equal to 28 by 22,400 into volume of nitrogen in ml at STP released by, okay, weight of or mass of organic compound into 100. In chemistry, mass and weight are same. We don't take acceleration due to gravity into the context. Okay, so then that is equal to 28 by 22,400 into volume of nitrogen gas released is 22.4 ml. 22.4 ml by weight of organic compound is 0.2 into 100. So 100, okay, 22.4 10 times. So 28 by 10 into 0.2 is equal to 28 by 2. Okay, so the percentage of nitrogen will be what? 14%. Understand? Right? So first of all, you have to understand the question. Then it will be easy. We have formula, we have procedure. Understanding the question is important. So to understand the question, first of all, you have to write what is given, what is asked. Then you can solve. Okay. Let us move to the next question. So that is all with Dumas method. That is all with the Dumas method. So these are all different questions, different model questions which are asked in JEE main previous year. Hope so you understood the concept behind this Dumas method, how to estimate the nitrogen in organic compound. It is very clearly microscopically explained. All the PVQ are also explained. You go through each and every point, each and every problem. Compulsorily, if you see previous year's questions, at least one question will be asked from this quantitative analysis. So concentrating on this quantitative analysis is very important. Understand the procedure, remember the formula, understand how the formula has been derived. Then you will be able to remember this formula if you go through the procedure. Thanks for watching. We shall meet you in the next session with a new topic.